class, and in this live class, I want to continue from this topic we started in our previous live class, which is longitude and latitude. Longitude and latitude. And this is about the geometry of the Earth. And we established that the shape of the Earth is spherical shape. Earth is spherical in shape, and it has the radius r of the Earth approximately 6,400 kilometers. And here also we discovered that on the surface of the Earth we have some parts which are very important. So whenever we are drawing the surface of the Earth, we just use our free hand. It's not the use of a compass, because here is not a circle, so it's a sphere. So we have the center of the Earth here, and a line passing through the center of the Earth, and this is called the polar axis. And thereby, this side is the North Pole, this is the South Pole, and close to the center here we have a line which is called the equator, and the equator is same thing as the latitude 0 degree. So we have equator, latitude 0 degree, and we also have a line also close to the center, which is vertical. And this here is called Greenwich meridian. Greenwich meridian. Sometimes we can shorten it as GM, and is also known as longitude 0 degree. So this is longitude 0 degree, which is Greenwich meridian. And now this means that on this side we have the west, this side also we have the east. That is, any line that is drawn horizontally on the surface of the Earth, that line is a line of latitude. So all lines of latitude are horizontal lines. So when we draw a line horizontal towards the north, so this line is a line of latitude and also is at the north. So we can say this is latitude north of the equator. Latitude north of equator. So that is that. And if we have a latitude here, so this is going to be latitude south. Latitude south of equator. And here, the highest degree we can go from 0 here to the north is 90 degree. So the maximum we can go here is 90 degree. Also, from 0 here to the south, the maximum we can go is 90 degree. Then the same thing applicable to longitude. So we can have a longitude at the west side of the Greenwich meridian. So we have a longitude here. So this longitude now is longitude west of GM of Greenwich meridian. And the highest we can go here is 180 degrees. So the highest degree of longitude we can have along the western part is 180 degrees. Then also when we have a vertical line on this east like this, so this is going to be longitude east of Greenwich meridian. Now this is the basic understanding of the Earth surface, and there is sometimes we use something called great circle and small circle. Great circle and great circle, these are all lines of longitude, and the equator, all lines of longitude and the equator. So whenever we mention great circle, all lines of longitude are called great circle, and also the equator is a great circle. So, but when we say small circle now, it means that all lines of latitude, all lines of latitude except the equator. So all lines of latitude are small circle, but the equator is not a small circle. You know, equator is also a latitude, but its latitude is 0 degree. So equator is not a small circle, but a great circle. So when we talk about great circle, all equators are great circle, and also, sorry, all longitude are great circle, and also equator is a great circle. But for small circle, all lines of latitude are great circle. Now, there's something important we need to understand here, that for latitude, it is represented as horizontal line, either towards the north or south. But for longitude, it is represented as what? A vertical line, either towards the west or towards the east. And also we established, if we check the previous class on this topic, we established that also on longitude and latitude, we call something ordered pair. So we have it in form of ordered pair. Whenever we are writing, it's always coming first. Latitude is always coming first. For instance, if you have a point A on the head, which is 30 degree north and 50 degree east. So what this one is saying is that this 30 degree north is latitude, and this 50 degree east is longitude. So that means this here 30 degree will be horizontal line, 50 degree will be what? Vertical line. Okay. So now whenever we see a point on the earth surface, so it's always written in ordered pair of latitude first, then longitude second. So we should always take note of that, that this is how we used to have it, latitude, longitude, and therefore also we should be able to locate places on the earth. That is, if we are given points, we should be able to locate where those points are on the surface of the earth. So that is part of what we looked at. Now let's look at locating places now. When we have some places, then we want to sketch their position on the surface of the earth. So we have some examples here. Example, here we have sketch the position. Sketch the position. So sketch the position of the following places. Of the following places on the earth surface. On the earth's surface. So let's look at the first one. We are given point A, and that point A is 15 degree north, 30 degree west. So 15 degree north, 30 degree west. And also number 2, we have point B, and point B is given as 15 degree north, 45 degrees east, 15 degree north, 45 degree east, and also we have point C, 0 degree, point C, 0 degree, comma 30 degree west. Then also we have point D, that's number 3 here. Then number 4, point D, and that is given as 0 degree, 45 degree east, 0 degree, 45 degree east. So we have the fifth one, which is point E, and that is given as 65 degrees south, 65 degrees south, then 0 degree, and number 6, we have point F, and that is 65 degrees south, 65 degrees south, 45 degree east. Now let's consider these places on the Earth surface. Let's locate them on the Earth surface. Now we draw the surface of the Earth. That is, the Earth is spherical in shape. It's not a circle, so we don't use compass whenever we are drawing it. So we just use our free hand, and we locate the middle, which symbolizes the polar axis, which here we have center hole. And you know that very close to that center hole, don't forget here, the polar axis here we have the North Pole, the South Pole, and very close to the center here, you have your equator, and this you label as equator. And don't forget that equator is same thing as latitude, 0 degree. So when we talk about equator, it's also a latitude, but it's of 0 degree, right? Now, also we have something called Greenwich meridian, very close to the center as well. And this line now, we call it Greenwich meridian, which is GM, and that is also longitude, and that's longitude 0 degree, right? Now, to start locating these places now, we have already established that here we used to have it latitude, comma longitude. So latitude must come first and longitude second. And don't forget that latitude is horizontal, while longitude is what? Vertical. Now, let's locate this point now. Point A now is 15 degree north. So this is north, this is south, of course, this is west, this is what? East side. And let's look 15 degree north now. Latitude, that's horizontal towards the what? North. So we draw this line. It's 0 here. You are starting from 0. So you are not measuring actually, but it's a sketch. So you know that the maximum you can get to here is 90 degree. So therefore, from 0 here, the distance will just be small from 0. So you can say this is our 15 degree. So we call this as 15 degree north. All right. Now, also we draw this side, which is 30 degree west. And that's the vertical line, right? Towards the west. And also, from 0 here, the maximum you can get to is 180. So it's just a sketch as well. We are not measuring here. So just draw a vertical line towards the west. And you now label it as, you can label it here as 30 degree west. That's our longitude towards the west, 30 degree west. And we see something here now, that this 15 degree north and this 30 degree west, the line cuts each other at a point here. And that is where point A is now. So we label this as point A. So we have successfully located point A on the surface of the earth. So this point A could be any country or any city. So each country, each country has the particular longitude is 42. Like London now is on the Greenwich meridian. So that is it. So every country is located on a particular longitude. So that is how to locate this particular place. Now, the same way we can locate this point B now. So, and what we have, the first one is latitude, 15 degree north. And we have already drawn that. We don't need to draw it again, so it's been drawn already. And the longitude now is 45 degrees. So that we are going to draw the longitude, which is vertical, towards the east, and it is 45. Just a sketch, so just draw the vertical line here somehow and label it as 45 degrees east. And what's happened? Where 15 degree north and 45 degree east meet. This is 15 degree north, right? And this is 45 degrees. So this point now is our point B here. So that is that. We have located point A and B. Now we can locate point C as well. And for point C, we have 0 degree. I know the first is latitude, right? Which latitude is 0 degree? That is the equator. So latitude that is 0 degree, of course, is the equator. We have already have the line here. This is the equator of latitude 0 degree. Then 30 degree west. We have already drawn that as well. This is 30 degree west. So where 30 degree west and the equator intersects here. So that will be point C. So this point will be point C. That's all. Then in the same way, point D is also 0 degree latitude, which is equator, 45 degrees. And also we have the line for 45 degrees drawn. So where it intersects with the equator here, that's our point D. And now point E is 65 degrees south. That's latitude, right? Latitude comes first, that's horizontal. So we draw our 65 degrees somewhere like this towards the south. You can label this as 65 degree south, that's latitude, and 0 degree. And this 0 degree now is longitude. And the longitude that is 0 degree is our GM. That's Greenwich meridian. So that's Greenwich meridian, and that's this line. So where this line meets with 65 degrees south, yeah. So that means we have point E here. Then in the same way for point F, that is 65 degrees south latitude, that is already drawn. Then also we have the longitude 45 degrees east, that's already drawn as well. So where they meet here, we have point F. So with whatever the places we are locating now, we should be able to locate it on the surface of the earth. Now from here we can deduce that here point A and point B, they lies on the same lines of latitude. So that's distance along the parallel of latitude. And since line of latitude are small circle, sometimes we call it distance along the small circle. So it's going to be useful later when we get there in this class. So we have something called distance along parallel of latitude. And that's the same thing as distance along the small circle. Okay. Now, but when we look at this point A and point C, they lie on the same longitude, right? And that makes it to be distance along longitude. And we can also call it distance along great circle, because all lines of longitude are also known as what? Great circle. Okay. Now, look at something here too. Distance between this C and this D, what can we call it? That's distance along the equator, right? And is also referred to as distance along great circle. Why? Because equator is also a great circle. So we have two major things that are a great circle, all lines of longitude and also the equator. So we use the same formula for when we calculate distance from A to C and want to calculate distance from C to D. So it will definitely be the same formula because they are both calculating distance along the great circle. So in the same way as well, when we want to calculate distance from E to F, E to F is along the parallel of latitude, right? And that's distance along small circle. Good. Then also from B to D is along longitude, that's great circle. D to F also is along the longitude, which is great circle. So now, you're welcome and once again to Master Tima's class. So thank you for joining us. Do well to subscribe and give a thumbs up. So thank you. Now let's look at some things like angular distance, angular difference, angular distance. So we have what is known as angular difference, and sometimes we call it angular distance between 2 points. Now, we can have angular distance along the same line of longitude. So angular difference on the same longitude, angular distance or angular difference on the same longitude. That is, when 2 points lies on the same longitude, as we have seen earlier in the diagram, we can find the angular distance between them. Let's look at these two examples. Find the angular distance between these following points. Number one, we have point E, which is 30° north, 45° east. Point E, 30° north, 45° east. And also point F, which is 25 degrees south, 25 degrees south and 45 degrees. So between these 2 points, we want to find the angular distance or angular difference. This is actually very easy, even without drawing any diagram, we can get it. And the shortcut is going to be given. Now, let's look at this. These 2 points lie on the same longitude, right? By the time we draw the diagram, look at the diagram, it should be like this. That is, you have the center of the earth, right? This is the earth surface. And this here, you have the center of the earth. If you like, you can quickly draw this as the equator, which is latitude 0°, right? And you have the Greenwich meridian, GM, which is longitude GM, which is longitude what? 0°. That's the reference point for latitude and longitude. Now, to locate these 2 points now, you can do that easily. 30° north. This is north, of course, south, west, east. And here, 30° north will be around this side. And you can label it as 30° north. And 45 degrees, that's longitude. So it will be on this side as 45°. You can label it as 45° east. And where 45 degrees and 30° north meet will be your point E, right? Same thing, your point F, that's 25 degrees south. That's latitude towards the south. So you can draw a 25 degrees south somewhere here, and you label it as 25 degrees south and 45 degrees. That has been drawn. This has been drawn to be 45 degrees. So where it meets with this 25 degrees south, that's our point F, right? Okay. Now, what we are finding is the angular distance or angular difference. So we can make a sketch. This is center hole of the circle now. We can make a sketch that here, since this is latitude 0° now, so angle between this center and this E is what is 30° because we move over here to this place 30°. So this angle is 30° now. Also, we move from center hole towards the south. and this angle to F from the center here is 25 degrees. Now, I want to find the angular distance between point E and F. That means the whole of this angle here is what we require, right? And when you look at that, that's simply 30 degrees plus what? 25 degrees. So therefore, angular distance here or angular difference here, whichever one you call it, same thing, is now equals to 30 degrees plus 25 degrees. And this gives us 55 degrees, right? Now, something important is here that we should take note. This is it. Or let's take the second example so that we are going to see the summary properly. So let's look at number 2 now. We have to find the angular distance between point G, which is 70 degree north, point G, 70 degree north, and 35 degree west, 35 degree west, and point H, which is 40 degree north, 40 degree north, and 35 degree west. Now let's consider the diagram as well. We can draw the head surface. It's just a sketch actually. So look at it. We have the center of the head here, of course, and we can draw our center hole and draw our equator very close to it, and we have our Greenwich meridian, and here 70 degree north, somewhere here, right? Because the highest is 90, so we can say 70 degrees here, north, and 35 degree west. This is west, don't forget, this is east. So draw your west somewhere here as 35 degree. So it's just a sketch. So this is 35 degree, right? So where 70 degree and 35 degree meet here, that's our point G. Okay. Then also point H is also north. So 40 degree, we are going from 0 upward. So it will come first before 70. So 40 degrees should be here, somewhere here, right? So this is 40 degree north. And where it meets with 35 degree west is here. So this is H. Now, I believe we can see. So let's look at this clearly. From here, this center, if we draw a line from here, that's the reference point because this is the equator, right? Then this angle from the center here to get to this line H, if I draw this line like this angle is 40 degrees now because that angle is 40 degrees. And also, we move from the center here to this point G. Also from the center that we move from here to this point, everything is what? 70 degrees. So let's write this out somewhere here at 70 degrees. So everything is 70 degrees. I believe we can see from here to here 70 degrees. Now, the distance we are interested in is from G to H, which is this place alone. And you know that if from here, from 0 here to G is 70, and from 0 to H is 40. Now, from H or G to H is now what? That will now be 70 degrees minus 40 degrees. And that will give us 30 degrees. So when you notice something here that for the first one here, what we did is that we added here, that is, we said this is 30 plus 25, right? And we got 55 degrees. That's the difference. And here we notice that we subtracted. That's 30 degrees minus 40 degrees. That gives us 30 degrees. Now, how are we going to? Because sometimes we don't need to show all this working. Because when we get to find distance along longitude, we just need to use theta. And that theta, for instance, distance along longitude, which is great circle, is given as theta over 360 degrees times 2 pi r. And this theta here is what is the angular distance that we are finding. So we don't have to show. Just do a little calculation and get the angular distance. And the summary now is this. Whenever it is on the same longitude, look at it. It's clear because why? We have latitude first, longitude second. And this here is latitude, and this here is what? Longitude. This is also latitude, this is longitude. Now we have same longitude, 45 degree, and that's why you see them being on the same longitude, 45 degrees. So now that is clear that is on the same longitude. Now what will determine the angular difference is the remaining angle here, which is the latitude. Now if the latitude is so that yeah, sorry for the break. Yeah, we have both of them lie on the same longitude. So what will determine the angular difference here now is the latitude, which is 30 degree north and 25 degrees south. But here something is important. Here we have north and here we have what? South. That's different direction. One is north. In this case, we have one is on the north and one is on the south. So north and south, that's different direction. So when we have different direction like this, the angular distance will just be addition. So different direction we had. Different direction, that is summary. For different direction, it will be addition. That is, if one is north and the other is south, that will be addition of the two angles. Now, that's for different direction. If it is on the same direction, so what we do is that we subtract the angle. Now let's consider here. You see, the second example given here, they also are on the same longitude. Yes, establish. They have 35 degree west, 35 degree west. Now, we consider the latitude now for the angular distance. And you can see that this is on the north, this is also on the north. So they are in the same direction. Same direction now, we subtract. That's why we have 70 degrees minus 40 degrees. So that is how we handle angular distance on the same longitude. And if it is on the same latitude as well, it's going to be in a similar way. So let's consider that if we are to do it on the same latitude, so let's look at the example on that as well. So now angular distance on the same latitude. Let's consider this example there. We have to find the angular distance between the following points. Find the angular difference or distance around the following point. Point A, that's first one. Point A, we have 40 degree north, then comma 35 degree west. And also point B, we have 40 degree north, then 50 degree east. So that's the first one. Now let's look at this. Something interesting here on the same latitude. If I want to use that shortcut we did the other time, I will say since they're on the same latitude, look at this. Their latitude are the same, 40 degree north, 40 degree north. Now, what will determine the angular difference now, angular distance now, is now their longitude. And something important here as well, this is on the west, this is on the what? East. So, different direction we do what? We had. So, we can just say that angular distance here or angular difference here will only be equals to 30 degrees plus 50 degrees. Because here it is on the west, here it is on the east, different direction. So addition, different direction, addition. So this is equals to 80 degrees. Now consider the second one as well. To buttress this, we have these 2 points given. 30 degrees south, point C. We have 30 degrees south, then comma 20 degree east. 20 degrees east and point D. Also, that is 30 degrees south, 30 degree south, and that's 60 degree east. Now look at it. Both are on the same latitude, 30 degrees south, 30 degrees south. Good. So these 2 points lie on the same latitude, and their angular difference will be determined by these 2 angles. And this is longitude, right? We determine by these 2 longitude. And this is on the east, this is also on the east. Same direction, subtract. So angular distance now, angular difference or angular distance will now be equals to 60 degree minus 20 degree. So we cannot say 20 minus 60 because we can't get negative, right? So that will be 60, the bigger one come first. So 60 degree minus 20 degree, and that gives us 40 degree. So that's the reason for angular difference, angular distance. So is either we add or we subtract. So that is how we handle that. Angular difference or angular distance on longitude and latitude. So that is that. And next, we can find distance between 2 places. That is distances along a circle. So let's look at that. Look at one example there. Distances along great circle. That was is called distance or distances along great circle. Along great circles. So the word great circles simply means longitude and the equator. So whenever we hear great circle, we have already defined that these are all lines of longitudes, all lines of longitudes, and the equator, So these are what they call great circle. So it has to do with the lines of longitude and the equator. And distance along this great circle is given by this formula. Distance D is equals to theta over 360 degrees multiplied by 2 pi capital R. Now here, this theta here is symbolizing the angular difference or angular distance between those 2 points, and pi could be given anyone that is given, be it 20 over 7 or 3.142, And this R here is same thing as the radius of the Earth, which is 6,400 kilometers. So that is that. So we have that formula as the formula to calculate the distance along great circle, the surface of the Earth. Now let's look at an example here. Find the distance between the following pairs of points on the Earth's surface. Find the distance. Example. Find the distance between, let's look at just one here, between points A, 30 degree north, 40 degree west, point A, degree north, comma, 40 degree west, and points B, 30 degrees south, 40 degree west, 30 degrees south, 40 degree west. So we have to take radius of the Earth R as 6,400 and pi as 20/7. Now let's consider the solution here. If the need be, we can make a sketch. That is, when we have this on the Earth surface, we can locate these 2 points on the Earth surface. Then we have the polar axis, center O, we have the equator, we have the Greenwich meridian, GM, and we have point A, latitude 30 degree, somewhere here. This is 30 degree north, and we have 40 degree west. So this is western part, this is eastern part, this is north, south. So this is west, which is 40 degree west now. So yeah, where they meet now, 30 degree north, 40 degree west. So we can call this our point A. Then point B, we have 30 degrees south. So we can call this our 30 degrees south. So this is 30 degrees south. Then 40 degree west. Also, this 40 degree west. So here we have our point B. That implies that here we have distance between B, A and B as the same on the same longitude. And that's why we call it distance along great circle. So whenever we have distance along the same longitude, it's the same thing as distance along great circle. So that is, here, we make use of this formula now. Then the angular distance here, we can write that out, which is theta. So theta here is going to be, because here they are the same longitude. Now we consider their latitude for the angular distance. That means the angular distance for this question now, because here is on the north, here is on the south. So that's different direction. So it will be 30 degree plus 30 degree. And that means theta here is what? 60 degrees, right? And we already have our pi to be 20/7, our height to be 6,400 kilometers. That means distance D, or we can call it distance AB. This distance along the line AB now is now theta, which is 60 degree over 360 degree times 2 times pi 20/7 times r, which is 6,400 kilometers. And here we just press our calculator and find distance AB is now equals to. So here, this gives us 6,704 6,704.76 kilometers. So that is that. That's how to handle the distance along great circle. So far we have looked at some subtopic here on longitude and latitude. So we stop here for today, and next class we continue from where we stop. And thank you for watching. Don't forget to subscribe and also share this video and give it a thumbs up. So see you next class then. Bye for now.